Hello, welcome to this lesson in Mastering Statistics. We're going to continue talking about the confidence interval. We'll work a couple of simpler problems. We're not going to get into the full glory here on how to calculate these confidence intervals just yet. I want to solidify some more fundamental concepts with them first. So these problems will be fairly simple in retrospect, but they'll be important for you to build your knowledge and understanding. So here we have the first problem. A survey of 200 males shows that they read on average of 15.7 hours per week. If the margin of error is 2.2 hours at a 95% confidence level, construct the confidence interval. All right? So there's two key things that you need to understand before you can solve this problem. The first thing is, we discussed previously that when we take a survey like that or a sample like that and get the sample mean, that the point estimate for the population mean is going to be equal to the sample mean. So here we're sampling 200 males, showing how often they read or how much they read, 15.7 hours a week. We're trying to find a confidence interval. That confidence interval is going to tell us how many hours per week the population will read at, and it's going to be a bound, a lower bound and an upper bound that will contain the population mean is what we're trying to do. So let's write things down. We know from the problem that the sample mean is equal to 15.7 hours. That is what we have surveyed, 200 males, right? And we also know the margin of error, E, we said we would denote that with E, is 2.2 hours. So this is hours and hours. And we need to calculate a confidence interval. Very, very simple to do, really. Once you understand and remember that the mean plus the margin of error is 15.7 plus 2.2. That will give you 17.9. And the mean minus the margin of error is 15.7 minus 2.2, and you get 13.5. Now, if you remember from previous discussions, we said that whatever we get for the sample mean, we're going to take that as a point estimate for our population mean. 15.7. So in other words, we surveyed these 200 people. We're going to assume, since the survey resulted in an answer of 15.7 hours, we're going to assume that the center of our confidence interval is at that point. We're going to assume as a point estimate that the population mean of the whole population is 15.7. We know that's not right. That's why we're given the margin of error. And so this confidence interval is going to extend up from the point estimate to 17.9. And it's also going to extend below that guy to 13.5. So do you see how the point estimate lies in the center of this thing that we're calling the confidence interval? So the way you write it down, the way you would write it down is you would say 95% confidence interval. Interval is the following. The way you would write it down is you would say that the population mean is less than 17.9 and greater than 13.5. The way you read this, for those of you who haven't done a math class in a while, when you have two inequalities like that and you have the thing of interest in the middle, this is the population mean. This is everybody in the population. The population is probably going to be males in whatever country or city you're talking about. And the parameter you're looking at is how many hours per week that they read. So we're saying the population mean is going to fall between these limits here. So that you read it from the inside out. You go here and you read this way. The mean is greater than 13.5. The mean is less than 17.9. So you can write it that way. Another way you could write it in terms of interval notation is just put the lower number, 13.5, comma, and then the upper number. Okay, I like representing it like this because I like seeing the actual variable there, but this is perfectly fine too. You're listing a confidence interval. So this whole answer is really it. Of course, you could choose to display it either way here. Now, why is it a 95% confidence interval? Well, we haven't really gotten into the details of that yet. In this problem, you were told that the margin of error was 2.2 hours at 95% confidence. So we're bypassing some details. In future problems, I'll give you the tools to be able to calculate all that yourself. Here you've been given the margin of error, and you need to construct the interval. So for your purposes, you just subtract the margin of error and add the margin of error. And just to make it absolutely explicit, the distance from the point estimate to the lower guy is the margin of error. The distance from the center to the upper part is also the margin of error. So you go from the point estimate down one margin of error and up one margin of error. That's how you construct the confidence interval. So similar type of problem, we'll just do it for practice. A survey of 600 people finds that they sleep an average of 10.5 hours per night. If a margin of error at 98% confidence interval is 1.3 hours, construct the confidence interval. So we're given the how many people we sampled. We're told what the sample mean is, 10.5 hours in this case. We're given the level of confidence, 98%, and we're given the error, margin of error, which is 1.3 hours. So really it's the same sort of thing. The sample mean after we do this surveying is 10.5 hours. The margin of error is 1.3 hours. And in this particular problem, it doesn't really matter the confidence level or the number of people we surveyed. That's just kind of extra information. In future problems, you will use that information to calculate the confidence interval. But here you've given the margin of error. So all you really have to do is say, okay, well, 10.5 plus 1.3 is 11.8. And 10.5 minus 1.3 is 9.2. You go plus one margin of error and minus a margin of error. And so to write that down, you can say we are 98% confidence interval, that the population mean is going to be greater than 9.2 and less than 11.8. Or if you want to write it more as an interval, open the parentheses and say 9.2, comma 11.8. Either one is acceptable. So what this is saying here, to interpret the results, what you're saying is you've constructed an interval that ranges from 9.2 to 11.8 in this case. And this is the number of hours per night that you get sleep, right? And we're saying that the population average is going to fall between these numbers. And we're 98% certain that if we could actually talk to everybody in the country and get us an answer from everybody and average it together, that the average number of hours per week that we get from that is going to fall between these boundaries here. So you see, it's really impossible to do that. If we could just get answers from everybody, then we wouldn't have to ever use really statistics too much. So what we do then is we sample a portion of people, we get an answer, and then we calculate this confidence interval and say, well, we don't know everything, but we're pretty darn sure. How sure? In this case, we're 98% sure that the population mean is going to fall in this interval. That's what a confidence interval is, and that's why it's important. It's very, very useful, especially when you're looking at manufacturing. You know, you might say you're 98% confident that your defect rate is going to fall within a certain range there of however many defects per week or whatever. But you can't study every single cell phone coming off the line, so what you do is you sample maybe 500 of them and get a good number based on that. Now these two problems have been pretty simplified because I've been given the sample mean and I've been given the margin of error. Right? Now in future problems, you're going to learn how to calculate this margin of error yourself, and that margin of error is going to be dependent on the level of confidence that you have there, and it's also going to be dependent upon your sample size. So we haven't done any of that in these problems. I'm just kind of crawling before we walk. Once you get that margin of error, though, all you do is you add it and you subtract it to get the confidence interval that you have. So follow me on to the next section where we'll build these skills. You'll continue learning about confidence intervals and how to calculate them, and we'll do it one step at a time. And I think you'll see this topic is one of the most useful in all of statistics.